Section 2.3 is titled Graphing Linear Functions. This should be something that you're pretty familiar with from Algebra 1 and Geometry as well. So we'll go through it pretty quick here. We'll talk about what makes functions linear, and then we'll look at how do we actually graph linear functions, and we'll look at different types of equations of linear functions as well. So what makes a function linear? I would describe it as having the same rate of change between points. Okay? In other words, if you have 2 points, let's just take a line. If we have 2 points on the line, whatever you go up and go across has to be the same to get to the next point, and the same to get to the next point, etc. Has to have a constant rate of change between points. That's what makes it linear. Now we have a name for that constant rate of change. It's called the slope. The slope is that rate of change between points on a linear function. It's also, I could describe it as the measure of the steepness of a line. Okay, knowing the slope tells us how steep it is, tells us what the constant rate of change is between points on a line. Now, in order to graph a line, you need to know 2 things. You need to know a point to begin at and a slope. So where to start, and then what's the rate of change to get to the next point and the next point and the next point, and so on and so forth. So let's look at a couple examples where we have just that given to us. Alright, so graph the following lines given point and slope. So this, we're told to start at -2, -1. And then we're told the slope is denoted with the letter M, is 4/3. Now what that means is that we are going to go vertically 4 units and horizontally 3 units, and then we'll drop our next point after we've done those 2. So think of it as, and you often hear this, rise and run. How much you go up and down, how much you go left and right. Okay, so to get to the next point, I'm going to go up 4, 1, 2, 3, 4, to the right 3, 1, 2, 3, and there's a point. Okay, between 2 points, we can connect with a line like that. Okay, the second example, the point is -3, 4. So we start at -3, 4. Slope is -1/2. Now the negative has to apply to the top or the bottom number. It does not apply to both. So let's just say we do it like this, (1/2). That would mean the negative direction vertically is down and right. So I'm going to go down 1, right 2. And I can do more points than just that. I can go down 1, right 2 more, down 1, right 2 more, and I can go as many points as I want that could fill up my graph. Okay. In general, just an observation here before we move on, positive slopes, as in this one 4/3, positive lines always go up from left to right. Negative slopes always come down from left to right. And we always read graphs like we read books, we read them from left to right. So going up, going down, positive versus negative slopes. Next, I want to look at a couple of different forms of equations of lines and how can we graph lines that are in that form. First one is standard form. Standard form is ax plus by equals c, where the x and the y are on the same side of the equal sign. What we're going to do, the graphing technique, maybe the easiest way to do this is to find the x and y intercepts. The x and y intercepts are the places where the line crosses the x and the y axis. If I can find those 2 points, I just saw on the previous slide that all we need is 2 points to make a line. We can find those 2 points and we can connect them and go through them with a line. So first example, 4x minus 3y equals 24. I would like to find the x and the y intercept. So the x intercept and the y intercept. We find them this way, really. Think about any point on the x-axis. Okay? Any point on the x-axis, like say this one right here, is the point 2, 0. Or this one right here is the point 5, 0. Or this one is the point -4, 0. They all have one thing in common, and that is that all the points that cross the x-axis have 0 as their y-coordinate. So to find the x-intercept, we're basically putting 0 in for y. Now, if I put 0 right here, then -3 times 0 just goes away. So to find the x-intercept, I just simply take the x part, set it equal to 24, as the y part goes away. If I divide this by 4, you get x equals 6. So the x-intercept is the point 6, 0. And there's a point. Okay, conversely, the y-intercept is found the same way. Every point on the y-axis has in common that the x is 0. So if I just take that away, I'd have -3y equals 24. Divide by the -3, so we get y is -8. The y-intercept is 0, -8. Put that point on our graph, and all we need is 2 points, and we can connect those 2 points with a line. And done. One more example doing the same thing. I want to find the x-intercept and the y-intercept. So for the x-intercept, we take the 8x and set it equal to what the equation equals, 32. For the y-intercept, we take the y part, set it equal to the 32. I divide by 8 here, and I get x equals 4. Divide by 4 here, get y equals 8. I do like writing them as ordered pair points. If we could go ahead and do that. So this graph crosses the x-axis at 4, crosses the y-axis at 8, and then we can go ahead and connect with a line. Trying to make your lines as straight as you possibly can. Use a ruler if you need to.